okay? Now, obviously, this is not going to give the most accurate representation of what's going on here. Can anybody think why? Can anybody think why this data might be unreliable?
Because the number of the attempt is too small.
Okay, good. So we didn't actually do it that many times. Like, there's quite a lot of us in here, and I only got you to do 3 trials. Okay, I only got you to do 3 lots of 5 trials. So each person should have thrown it about 15 times. And like I say, there's some people in here who only threw it 1 trial. Some people only threw it 2, right? So actually, you're dead right. In order to increase the reliability of this, we should throw the beanbag more times. But can anybody think of some problems with throwing the beanbag more and more times? Absolutely. You start getting a bit of skill. Like the first time you did it, you probably weren't that great because you're like, okay, I need to sort of train myself. But eventually, the more you do something, you get that training effect, okay? And this is a real life thing, okay? When you're doing experiments, you need to think of this. Like I know there's some psychologists in here, okay? You need to be aware of the different effects which you can have. And training effect is a very real example, okay? So this is why you try and ask people to do different things each time. Okay? So in an ideal world, what I would like is to have people of roughly the same skill level to only throw the beanbag or only do the trial once. Yeah? I don't want to be doing the same thing, getting the same people to do the same thing over and over again. Okay? There's also an issue as well that people have different skill levels. Like I personally am really rubbish at throwing. Okay? But there might be some people in here, I think Mohammed, you got it 1 time, didn't you? Like every single time was a success, right? So different people in here have different skill levels. So if you wanted to make this fairer, what you should do is realistically separate them into people that are skilled, people that have medium skill, and then people which are low skill as well, and sort of see the different results there. Whereas I just bundled you all together, okay? So all of these things you have to think about when you do an experiment, okay? What are the limitations? How can you improve those? Is that okay? Okay, good. So very quickly then, could I ask you to discuss these 6 words on the board? So you've got variable, you've got discrete variable, you've got fixed trials, success or failure, independent and binomial. I know we've met some of these words before, but I've put the words which I think are most pertinent to this particular type of distribution. So can I give you 3 minutes to discuss what you think these words mean? Okay, so I was going to get you to discuss, but I think you all pretty much have it open on your screen in front of you anyway, so there's no really point discussing you. Okay, so in this case, what would the variable be? Yeah, it's just simply the number of times that you get a success in those 5 trials. Okay, why is this situation discrete? Why has it got to be an interval number? Yeah, exactly. It doesn't make sense for the beanbag to land 1.5 times on the piece of paper. It doesn't make sense. Yeah, we say it's either in the circle or not in the circle. It can't be half in the circle. Okay, so it has to be an integer number of times. It has to land. Okay, why is it fixed trials? What do I mean by fixed trials? Do you think? Yeah, exactly. So the number of times that I throw the beanbag each time is fixed. I've said you throw it 5 times. Not 4 times, not 6 times, not 10 times. I say throw it 5 times. So I'm fixing the number of times that I'm doing the experiment. So I'm fixing the number of trials. Okay. What do I mean by success or failure? So what's the success in this case? We've talked about this one. In the circle, and failure is out of the circle. Fantastic. Okay. What does independent mean in this situation? Good, so if you get it in the beanbag, so if you get the beanbag in the circle on like a throw, that's not going to affect the chances of getting the beanbag in the circle on the second throw, okay? So each time you throw the beanbag, you're assuming that it's independent, okay? So getting the beanbag in the circle is not going to affect the chance of getting the beanbag in the circle on the next throw. Does that make sense? Okay, good. So why is this binomial? Good, so there's 2 outcomes, right? So because there's 2 outcomes, then we know it's a binomial situation. So this here on the board, okay, this here on the board are the conditions that you have to check in order to see whether your situation is binomial or not, okay? So remember last time I saw you, we were using these, we're using these, right? So the uniform distribution. What was the condition we had to check for the uniform distribution? What was the condition we needed to check if it was a uniform distribution? So each outcome had to be the same, absolutely. So each outcome we're expecting to be the same. Then we know it's a uniform distribution. If you can check it, and if all of these 6 things are satisfied, okay, so particularly fixed trials, is it discrete random variable? Is it either success or failure? Are all trials independent of each other? Then we know it must be a binomial situation. Okay, so you remember this thing with probability distributions. I'm trying to show you the different types of distributions that you can have. And you have to check different characteristics depending on your situation to see whether it satisfies a binomial distribution, a uniform distribution. In a minute, we're going to do the Poisson distribution. Okay, so all of these distributions, you have to check the different characteristics to see whether you can apply some model to it. Is that okay? Yep, good, fantastic. So let's have a look at this. So what are the 2 parameters that we are interested in? So a parameter is the thing which can change. Okay, so what are the 2 parameters of a binomial distribution, do you think? So have a look at what we did. I can give you one. That thing. What's that? Good, so it's the number of trials you're doing. Okay, so the number, sorry, I can't spell number. Okay, so we need to know the number of times that we're doing this. Okay, so in this case, I told you, throw the beanbag 5 times. Throw the beanbag 5 times. Okay, what would be another parameter of this distribution? The probability of, exactly, the probability of a success, okay? So you need 2 things in order to characterize the binomial distribution, okay? So this is how we write it, and pay attention to this because it's a little bit weird, but it's really fundamental. So we start off with our random variable, which is x, okay? And we say that x is going to be binomially distributed. So we use this symbol for show to distribute. Okay, it's a tilde, okay? So x is going to be distributed under a binomial situation. And we just write b to represent binomial, okay? And then using our brackets, we write the 2 parameters that we are interested in, okay? So one of the parameters we're interested in is the number of times that we do this trial, okay? The number of times we throw the beanbag. I'm going to call that n, okay? So that's the number of times, the number of trials. Okay. We said the other parameter we're interested in is what is the probability of getting a success? I'm going to call that P. Okay. So P is the probability of success. Right? So this is simply how we write the probability of the random variable x if it's a binomial distribution. Okay. So what I've done on the board there is I've assumed that 3 out of 5 trials is probably the most common. So 60% of the time we should get a success. Okay. Of course, our data comes out slightly differently, but like we say, we've discussed the limitations of why it might change. Okay. So for example, training effect. For example, we didn't do it enough times, etc., etc., etc. Okay. So I've just said assume that we know n equals 5. That's the number of trials. And that the probability of success, let's say we get 60% of the time a success, okay? In which case, our binomial distribution, we would write like this. So x, our random variable, will be binomially distributed. Well, n is now 5, and the probability of success is 0.6. So this is what you would see written down on paper or in a textbook, okay? But there it is in general as well. So this is in general. This is specific to our example. So the first number you notice is always the number of times you throw it. The second number is always the probability of success. Okay? Are there any questions about that notation there? Is it all clear? Yeah?
The B refers to binomial?
Yeah, the B just stands for binomial. Okay? And as you become more familiar with this, in fact, in the next hour, we're going to look at the Poisson distribution. This will change to something different. We'll look at the normal distribution later. This again will change. Okay? So the B stands for binomial. okay? And this stands for is distributed. So x is distributed binomially using these parameters here. Is that okay?